Okay, so we are going to pick up where we left off yesterday. Did I do the whole top part of it? Or did we just write the rule real quickly? Okay, we wrote everything down. So then can I have someone please remind me what is our quotient rule? If I have x to the a divided by x to the b, what do I do to the exponents? I'm going to subtract them. Good. And last night on your homework, there were some problems that required the quotient rule. And I saw some of you subtracted. But we subtracted wrong, okay? So we need to make sure we're subtracting correctly. If I have 1 in the numerator and 2 in the denominator, 1 minus 2 is not 1. That is negative 1, okay? And we'll see some more negative exponents today, and that's another reason why I wanted to wait, because we haven't gotten that far yet, okay? So we're going to practice some quotient rule problems that are a little bit more similar to what we did yesterday, or that what will show up on your homework. Then we'll finish with our last 2 rules, okay? So if you weren't here yesterday, this is what we had. If you weren't here yesterday as well, I also recorded the video from class. Okay, so we are going to, I'm going to skip number 13, okay? Because if we can do number 14, number 13 is embedded within it. So number 14 has one additional step. So that's the one we're going to start with. So on number 14, I have a division sign, which means use the quotient rule. What else do I have on number 14? I do have x and y. Those are my variables. What else do I have?
An exponent outside of the parentheses.
I have an exponent outside of the parentheses. Good. So that tells me the power rule. Now, are those parentheses around the whole fraction or only a part of it?
The bottom numerator.
Only a part, the bottom, the denominator part. Okay, the bottom is the denominator. So that means that exponent outside only distributes to the denominator. So I'm going to distribute it to the 3 parts inside my parentheses. Okay. Have I touched the numerator yet? Have I done anything with that? No, so I'm just going to rewrite that for now. 12 x to the 9th, y to the 4th, okay, divided by. And then when I distribute it, I'll get 4 squared x squared y squared. What is 4 squared? 16, good. Then I have x squared y squared. Now this step right here that we're at now, that looks like number 13. So that's why I wanted to skip number 13, because it's within the problem. Now, I have 3 different parts of this. I have my coefficient term, I have my x term, and I have my y term. And I can solve these each separately. So I have 12 over 16. I have x to the 9th divided by x squared. And I have y to the 4th divided by y squared. Okay. So what is 12 divided by 16? Does it divide neatly? Or does it give me like a whole number answer? No. But can I simplify 12 over 16? Yeah. The numerator and denominator are both divisible by one number. What is it? They're both divisible by 4. Okay, so 12 divided by 4 is 3. And what's 16 divided by 4? 4, good. Okay, so 12 divided by 16 simplifies to 3 over 4. That doesn't simplify any further, so I'm going to leave it. And we're going to use it as part of our answer. Okay, what about x to the 9th divided by x squared? X to the 7th, because I have x to the 9 minus 2 is x to the 7th. So that's another part of my answer. And what about my y values? What do I get here? Y to the 2nd, because 4 minus 2 is 2. So now those 3 elements that I've boxed, we're going to combine them all together to get our answer. And there's 2 ways of writing this correctly. I can write 3/4 x to the 7th y squared, or I can write 3x to the 7th y squared and put the whole thing over 4. But these are both the correct answer. You only need to write one of those on a test or a quiz, but they are both acceptable answers. Okay, questions on 14, or is that one okay so far? That one's okay? You guys awake today? Are you more quiet because it's cold outside? Is it cold outside? It looks like it.
It's raining.
Is it really? And let's keep going. Number 15. There's 2 ways to do this. On number 15, there are 2 different ways to do this problem. Okay? The way I like to do it is the way I'm going to show you first. I think it's the easier way. What do you mean I can't do that? What's that? Like distribute it and divide like that? Or what are you asking me, Diego?
Can't do that. Like, that is more simple than just
What looks more simple? Are you saying break it up?
break it up like
Yes, but there's other things happening first. We're going to break it up the same way, but see how on number 15 I have parentheses around the entire thing? That means that I would need to distribute to everything, all 6 of those terms. But that's not the way I like to start the problem. That is a way to do it, but the way I prefer is, you see how this whole thing is inside the parentheses? See what I'm talking about? What would you say? Yes, I want to simplify that first. Okay, because then I'll be working with less terms. So if I break this up into my different parts, I have 4 over 5, a over a, and b squared over b. What is 4 over 5? Does that simplify any further? No. What about a over a? What is a divided by a? A divided by a is a?
0. It's not 0.
It's not 0.
So 1.
It is 1, because remember, anything divided by itself
Lame.
is 1. Why is that lame? You've been doing that since you learned to divide. Okay, if I give you 10 divided by 10, don't tell me it's 10. What is 10 divided by 10? 1. Don't tell me it's 2 or anything else either. What is 100 divided by 100? 1. What is negative 50 divided by negative 50? It's positive 1. Negative divided by a negative is 1. Anything divided by its exact same self is just 1. So a divided by a is 1. What about b squared divided by b?
1b.
b squared divided by b.
B squared.
What is 2 minus 1? 1. So it is just b. Okay, are we back on the same page? Does that make sense? Okay. So since I have a divided by a is 1, I'm just going to not worry about that part, because if I put it into the problem, multiplying by 1 just gives me the same thing that I already had. Okay. So I'm left with a 4/5 and a b. So I'm going to take that 4/5 b and put it back into the parentheses. Okay. Because I just simplified the part that was inside. So now I can distribute my square to every part. So I have 4 squared divided by 5 squared times b squared, which is 16 over 25 b squared. And that's the final answer. Okay. I'm going to erase the work from number 14. Number 14, we're on 15 now. So I'm going to erase the work from the previous question, because you should have that. Because I'm going to show you the other way that you can do it. But this other way runs the risk of you forgetting to simplify things. Okay. So this one, yes, it can be dangerous. Does that make it wrong? No. But you have to be more careful. Okay. So since that exponent is outside, I'm going to distribute to everything inside. So how many things did I have to distribute the exponent to? 6 things versus the 3 when I simplified first. Does that mean this way is wrong? No, but remember, sometimes there's a better method in places. Like, remember when we did our factoring unit? You can always use long division, but sometimes synthetic division is a better way to do it. Just like this way will always work, but simplifying first is normally easier. So this gives me 4 squared a squared b to the what power? B to the 4th power, good. Over 5 squared a squared b squared. Does that make sense so far? Okay. So I can separate it the same way. Okay, so I get 16 over 25. What's a squared divided by a squared? That is just 1 again. And what about b to the 4th divided by b squared? B squared, because 4 minus 2 is 2. So that means I still have 16 over 25 and b squared. And is that the same thing that I got the other way I did this problem? Yeah, but I just did it in a different order, okay? I did the same kinds of steps, but I did it a little bit different. You like the red one better? Okay, that's the one I prefer, but I showed you both because you can do either. You like the second one better? Okay. I'm going to have you do 2 U tries right now. Okay. You are going to try 17, and you're going to skip 16, because if you can do 17, you can do 16. JJ, 16 is the easiest one on the stage. Yes. Okay. But if you can do 17, you can do 16. So do 17 and 18. It is 3x to the 5th quantity squared divided by 27x cubed. And the other one is 12x to the 5th divided by 15x. All of that is squared. Okay, here are our answers for 17 and 18. What question? What question? How is it 1/3? Did you get 9 over 27, Helene? You got 1 over 9? Because I know what you did. You forget to distribute the, yes. Because the 3 becomes squared, so it's 9 over 27 is 1/3, yes. Okay, and then on 18, if you didn't simplify first, you got 12 squared over 15 squared, which you should have found, is 144 over 225. That's not simplified. On a test, you would not receive full credit for that problem because it's not simplified. Okay, that's why I recommend 12 over 15. Simplify that to 4/5 first because both are divisible by 3. And then 4 squared is 16. 5 squared is 25. Okay, does that answer the questions that we had or the mistakes that we made? Do you need me to answer any other questions on these 2 problems? Okay, then we're going to move on to today's work. So this is still from yesterday. So if you need a new page, you can start a new page. So we're going to talk about our sums and our products. And my first 2 classes struggled with this a little bit because I know I'm throwing a lot of rules at you all at once, and I'm sorry there are 5 of them. You should have done all of them last year, I think. You've done most of them. I know for a fact because my Avid classes were doing it before break, and they're in the 10th grade. They have IM2 prep classes. Is that where you came from last year, Diego? Okay, so I know you did this last year, whether or not you remember it. That's why we're doing a lot of it this year again. But this part right here goes back to when you first learned how to add and subtract and use variables, which was either in IM1 or before that. So we're going to talk about the sum. If I have 0x, what does that equal? 0. How many x's do I have? I have 0 x's. Okay, so 0x is 0 because I have 0 x's. There is nothing there. Okay. When I have 1x, how many x's do I have? 1. Okay, so I'm going to write that as 1x. When I have 2x, how many do I have? 2. Okay, so what that means is I have 1x plus 1x. How come 1x plus 1x isn't x squared? Because that's what you always tell me it is. Because you combine your x's. If you have 1x and 1 more x, that means you have 2 x's, okay? And that comes back to the problem from our warm-up, okay? When I was subtracting, 64 minus 6 was 58, not get rid of all the variables, okay? The next thing I have is 3x. How many x's do I have? I have 3, so I have, 1x plus 1 more x plus 1 more x, because this is a sum, and that's what we're doing. We're adding them up. What about for 4x's? How many do I have? I have 4 x's. 1x plus 1 more x plus 1 more x plus 1 more x. Okay, does that make sense so far? And I know you're like, oh my gosh, why are you doing this? I know it. Because on the next slide, on the first question, there is a very good chance we're going to make a mistake because of this rule right here, okay? Now for our product rule, x to the 0.
1.
X to the 0 is 0?
1.
It's 1. Do you remember why it's 1? Because it's a 0 rule. It's not an imaginary number. That's I. Okay, it is a very real number. It does exist. Okay, but this is 1 because I do have x's. And I'll come back to this and explain it after we get to the rest of them. Okay, so if I have x to the first power, how many x's are there? There is 1x. And this time it's a product, so I'm multiplying, okay? In x to the squared, how many x to the squared? X squared, there are 2 x's, and they are being multiplied together, okay? X cubed, how many are multiplied? 3. Okay, and x to the 4th, I'm going to multiply 4 of them, okay? So when we go back to x to the 0 power, I can't multiply by 0 x's because that will give me 0, because multiplying by 0 is 0. So instead, if I multiply each time, I have multiply by 1, multiply by 2, multiply by 3. If I'm going backwards, what do I do? That's the opposite of multiplication. Division. So once I go beyond that, I'm going to start dividing. So to get 1, I have my original x, and instead of multiplying by 1 more x, I'm going to divide by 1 more x. And what is x divided by x? That is just 1, because it is x to the 1 minus 1, which is x to the 0, which is 1. Okay? So if I'm getting larger, I'm multiplying, and as I get smaller, 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 that means I divide by more and more and more x's. Okay? And if you remember, I don't know if you all did this in chemistry, but when you have, what's it called? You've all seen this in your science class. Scientific notation. When you are converting between different measures, when you're converting from like milligrams to grams and so on, you are adding like 10 to the second or 10 to the negative 3. 10 to the negative 3, we'll talk about that today, okay? Not that one specifically, but that means a division sign, okay? So here is our first rule. It's called the 0 exponent rule. If we use our normal product rules, I have x to the, what am I doing with this 9 and 0? Am I adding, subtracting, or multiplying them? I am multiplying. This is the power rule, which is x to the 0, which you all told me was 1 before. Okay, what about on number 2? Am I going to add, subtract, or divide? I mean, add, subtract, or multiply. We don't divide these ones. I'm going to subtract them, which is, again, a to the 0, which is just what? 1. Okay, so our rule, x to the 0, is just 1. Anything raised to the 0 power is 1. Okay. What if I had 1 million to the 0 power?
0.
It's still 1. What if I had 1,234,679,000 to the 0 power? That is still 1. Anything to the 0 power is 1. Okay? Are you ready to try an example of this? No, you're not ready? Oh, you're ready? Okay. Are we done copying this down? Okay. So, our first example is 3x to the 0 times y, all raised to the 3rd power, plus y to the 3rd power. Now, do any of those have an exponent of 0? Yes. Which one has an exponent of 0? The x to the 0 power. Okay. So since I see x to the 0 power, the thing I like to do is cross it out, because it equals 1. And remember, since I'm multiplying, that would be 3 times 1 times y, which is just the same thing. So I can bring down the 3 and the y, cube it, plus y cubed. Does that make sense? Do you understand where the x to the 0 went? Okay, it doesn't disappear. I don't want you to think, oh, she just got rid of it, crossed it out, it disappeared. It didn't disappear. X to the 0 is 1, but when I multiply that to everything inside, it doesn't change their values. Okay. So what do I do next? What does that mean? Yes, distribute. Good. Okay, so I have 3 cubed, y cubed, plus y cubed. So, what is 3 cubed?
27.
Do we know what 3 cubed is? That is 3 times 3. It is 27, yes. Y cubed plus y cubed. What is this answer? How do I combine these? They're like terms. What is it? Is it... I heard a couple of you say it. I want you to be more confident. 20... Yes. 28 y to the 3rd power. Okay.
Oh.
Because there is a 1 right here. I have 27 y to the 3rds, and then I have one more of them, which is 28. Somebody in my last class asked me a really good question, and I wanted to share it with you. He said, what's the difference between this? So what's the difference between this and with the parentheses like that? Can you guys tell me what is the difference between those two things? Yeah, one is being multiplied. So the top one, which is what we had, is being added. So that means I have 27 units, and one more unit is 28 units. What would the bottom one be with the parentheses? That would be 27y to the what power? Not 9. To the 6th power. Okay? Because that's when I add my exponents, and that's where you make those mistakes. Does that make sense, the difference between these two? Okay. We're going to keep going. Number 20. I'm going to rewrite this over to the side so it's not squished in the corner, so hopefully it's a little bit easier to read. What is the first thing that we should do? What do you think? Is there anything to simplify first?
Yeah, there.
What?
The 16.
Okay, the 16 and 2. What does that simplify to become? Okay, do we all agree 16 divided by 2 is 8? Okay. So I have 8 b to the 5th over b to the 5th minus b. What else can I do? What about the b's? The 5 b's, what do I do? Subtract them. Okay, so I have b to the 5th minus 5 is b to the 0. Or at the same time, I can cross them out like that. If you don't want to write it all out, or you don't want to write your subtraction, if you have the same number of them, you can cross them out. So now I have 8 minus b. Can I simplify this any further? No, so that's going to be your final answer. Sometimes you can't combine like terms. Okay. Questions on these two before we move on? No. I know, it's almost lunchtime. Okay, we're going to move on. Now I'm going to have you try number 21. Skip 22 for now. You try 21. I'm going to give you 1 minute for 21. Let's go. Okay, here's the answer for 21. We're going to check it. Did you get that? Some of you got 16 instead of 8. 4 times 2 is 8. Yes, 2 cubed is 8. It is not 4 times 4. It's not 4. 4 times 2 is 8, not 4 squared is 16. Okay? Do you understand why that's the answer for 21? No? Okay, I will go over it quickly. Okay, the y0... I would like it like this. Okay. The y to the 0 cancels. Did we get that part? Okay. Then this cube distributes. So I have 4x squared minus 2 cubed, x cubed. Like that. I don't distribute the negative through. You distribute a negative when you have plus or minus inside the parentheses, and I don't have that. It's just multiplication. Okay. I want to move on now. We're going to move on to our last rule because it is on your homework. Okay, here's our last rule. So I have x to the 4th divided by x to the 6th. This is my quotient rule. So when I divide, what happens to the exponents? I subtract them. What is 4 minus 6? 4 minus 6 is 2. What's 4 minus 6? Okay, negative 2. Okay. But we don't like negative exponents. Because we just don't. I don't have a good answer for you, but I'll look it up and see if I can find a good one. So since we don't like negative exponents, we have to turn this into a positive exponent. Actually, it has to do with reciprocals. So instead of doing this, let's go back to our day 1 when we expanded everything. 5, 6, okay? And I can cancel out all of those. How many am I left with? I'm left with 2. This one canceled right here. And are they in the numerator or in the denominator? Denominator. What's left in the numerator? A 0? These all divide. So there's not 0. They don't disappear. It's a 1. Okay. So we're going to skip the numbers 1 and 2. What this means for our rule is that when you see a negative exponent, turn it into a fraction. Okay. Put it on the bottom, make it positive with a 1 above. The other way we might see that is like this. We're going to move it to the top. And we don't even actually have to write that divide by 1 part for here. Okay, so write these two together, and then I'm going to try one. I want to get through 2 examples, okay? They're very short, but the bell will probably ring. I'm sorry, but I want you to stay, okay? Because I do want to just get through these 2. That way you have them at least written down so you have an idea when you start your homework tonight, okay? You ready to move on? Okay. These are our last 2 examples today. We're going to do number 1 and number 4. So when the bell rings, please stay seated. It will be quick, I promise. On number 1, this is the same as saying 3 times m to the negative 2. Do you see how on number 2, the whole thing is in parentheses? These parentheses tell me that everything gets the exponent. Without parentheses, that means that only the thing touching the exponent gets it. Okay? So if I have m to the negative 2, how do I make that positive? Put a 1 where? Okay, so I'm going to put a 1 over, and then the exponent becomes positive. Does that make sense? It changed and becomes positive. I still have a times 3. So this becomes 3 divided by m squared. Is that okay? Yes or no? Okay. Because this rule, I know it's the most difficult one to grasp. Okay. For number 4, I have to do the power rule. So what do I do with each of those exponents? Distribute them through. Please wait. Okay. We're almost done. So I get x to the what power? Help me out. The faster we're done, the faster you can go. X to the negative 4, y to the negative 6, then what? Negative 15 and negative 12. How many x's do I have? I have x to the negative what power? I have negative 4 and negative 15 is negative 19. Negative 6 and negative 12 is y to the negative 18. And how do I write that with only positive exponents? 1 over x to the positive 19, y to the positive 18, okay? Thank you for staying. Do your homework tonight. Have a nice day, and I will see you tomorrow.